Okay, let's try and finish this problem up. It froze before I finished this diagram. So let me go back and see if I can explain to you what I did. So I drew some random function here. We were looking at this integral from 1 to 3. I drew two rectangles in here. This distance at the end of the first rectangle is delta x. So this spot is 1 plus delta x. This spot right here is going to be 1 plus 2 delta x. So it started here and went on delta x here and then went on a delta x here. So what's going on inside of here is to identify those x values that will be used to determine the height. The first one is going to be at 1 plus some delta x. But then the second rectangle will be at 2 delta x, and the third rectangle will be at 3 delta x, and that the fourth rectangle will be at 4 delta x. So really what this is how many delta x's are you going to add on is I. This is your counter down here, I delta x. So, and then one other thing, we can clean up this delta x. We can make that a 2 over n. So that this limit is actually the limit as n approaches infinity of the sum from I equals 1 to n of f of 1 plus I times delta x, which is 2 over n. So I times 2 over n times a 2 over n. That's the answer that they're looking for right there. Okay, so I'm sorry that it had to split over 2, but hopefully that helped on this one. They gave you 1 point for coming up with delta x is 2 over n. 1 point to write this. And then 1 point for the inside, for the summand, which is the inside. Okay. Thank you very much, and again, sorry about my hover cam freezing.